Okay, here we are on Chapter 4 Fractions, and we're looking at Section 4.3 on dividing fractions. So the multiplicative identity property. So if we let a over b be any fraction, then if we take a over b times 1, we get a over b back. Or if we take 1 times a over b, we get a over b. So the number 1 is called the multiplicative identity because the identical number is returned when you multiply by 1. Now we have the multiplicative inverse property. So if we let a over b be any fraction, then basically the reciprocal, b over a, is called the multiplicative inverse or reciprocal of a over b. Now the product of the two reciprocals, this a over b times b over a, is going to give us 1. And so we're just going to flip the fraction over to get the reciprocal. So we start with the a over b, take the reciprocal, which is b over a. When we multiply that, that gives us 1. Okay, so we're just flipping our numerator and our denominator. So with this one, it says to find the reciprocal. So remember, we just flip them over. And because usually we keep the negative and then up here or out in front, we'll just keep the negative up here. And so now it becomes 9 on top and 4 on the bottom. And so negative 9/4 is the reciprocal of that. All right, what about 19? Well, think about that. That's really 19 over 1. We've dealt with whole numbers and then having to convert them to fractions. And so if we multiply by the reciprocal, it goes 1 over 19. And so that's what we get for the reciprocal. Now, if we multiplied this, what do we get? Well, on this one, a negative times negative is positive. The 4's cancel, the 9's cancel, we get 1. So, that one checks. And here, the 19's cancel, we get 1, and 1 over 1 is 1, so that one checks too. All right, so what if we want to divide fractions? Say we have a over b and c over d. They're any fractions, doesn't matter what they are. Then if we take a over b divided by c over d, what do we do to actually do that? Well, what we have to do is we keep the first fraction the same, like we have here, change it from divide to multiply, and then we take the reciprocal of the second fraction. So what we're doing is keep the first one, change it to multiply, and then flip it over and have the reciprocal. So basically, keep, change, flip is how it works when we do these. So when you do it, you can say, keep, change, flip, KCF, and that's how we're going to look at these. And that's how we're going to do the division is through multiplication. So if we do that, that becomes 2 over 5 times 5 over 11 because we just flip this one over and change it to multiply. Now, we've been doing this already before, and so that cancels that. Those are both 1. And so now what do we have? Well, we just have 2 times 1, which is 2, 1 times 11, which is 11. So 2/5 divided by 11/5 is going to give us 2/11. All right, what about this one? Well, we're going to keep that and we're going to change and then we're going to flip. So keep the first one, 15 over 7, change to multiply. Now remember, this is 5 over 1 because it's a whole number, and so that becomes 1 over 5. Okay, now it looks like we can do some cancellation. 5 goes in here once, 5 goes into 15 3 times, and that gives us finally 3 over 7 as our solution because 3 times 1 is 3, 7 times 1 is 7. All right, so we're going to keep, change, flip. So 7 over 25 stays, change it to multiply, and then we flip this one, so it's 35 over 56, and we'll make the negative on top here. All right, so now what do we have? Well, it looks like 5 will go into here 5 times. 5 will go into here, and it's going to be, when we get done, it's going to be a negative 7. All right, and so what is something here? Can we cancel the 56 with the 7? So if we take 56 and divide it by 7, we should get 8. And so that means we can take 1 here, 8 here. And so now nothing else reduces. So we have 1 times negative 7. So, well, let's go ahead and change it back so we kind of keep consistent. That's going to be a negative 7 over 5 times 8, which is 40. Okay, maybe we'll erase that, make it a little nicer. All right, so negative 7 over 40. All right, continuing on, we're just going to do the same thing. Keep, change, and flip. So that gives us negative 15 over x times, now we have x to the fourth, and it's going to be a negative because we're going to take that 9 and just make it a positive on the denominator, keep the negative up here. Now remember, a negative times a negative is positive, so those become positive. Now here we have 3 goes in here 3 times, 3 goes in here 5 times. One of these cancels one of those. And now it looks like we're done with cancellation. So let's change back. And so what do we have? We have 5x to the third over 1 times 3, or 3. Okay. And at any time you want, go ahead and, before I start, pause it, do the problem, and then start up again and see if you get it right. So we're going to keep, change, and flip. So negative 22 over 7 times 17 over 18, and it's also a negative. So what does that mean? Well, negative times a negative is going to be positive. Now, let's see. Here we have 2 times 11, 2 times 9. So 2 will go in here 9, 2 will go in here 11, and 7 and 17 are prime. So that's as far as we can go. So looks like we probably are going to have to do a little multiplication. So we'll take 17 times 11. So 1 times 7, 1 times 1, and 7, and then 1. We get 187 for the numerator. And 7 times 9 is going to give us our 63. Now, if you hadn't reduced it, then you would have had to take 22 times that, and then 7 times 18, and then you would have had to determine, what's the common factors there, and that would have been a little more difficult. But with this way, we know it's reduced as much as possible because we're down to primes, and we're done. All right, so again, keep, change, flip. So we have negative 6 over 1. We're going to go ahead and make that a fraction. That's really over 1. And times, and we'll have 21 over 20. All right, so now we have that written. Let's start canceling. So looks like 2, oh, we got a weird color there. 2 will go in here, and we're left with 3. 2 will go in here, and we're left with 10. Now that's about as far as we can do. And so now we have to take 21 times 3. So if we need to, we can go ahead and multiply and get our 63. And it's a negative. And then we have 1 times 10 is 10. All right. What about this one? Well, again, keep, change, flip. Now this is again negative 8 over 1. So that becomes 2 over 9 times 1 over 8, and it's a negative. Now let's go ahead and put our colors here. 2 will go in here once, 2 will go in here 4 times. So that's as far as we can reduce. So 1 times negative 1 is negative 1. 9 times 4, that gives us 36. Okay, so that's all these we've seen so far. So nothing is hard. We just cancel. We've done cancellation when we multiplied, and so we're good to go hopefully on this. And so that's how we're doing this. Keep, change, flip so far. All right, how about some more? Now we're having more variables. So if we keep writing our KCF, if it lets us, then we have 18y to the 6 over 7 times 9 over 14y to the 4th. And that's going to be equal to what? Well, 2 will go in here 7. 2 will go in here 9. Now, 4 these cancel, and 4 those cancel, so we have left with 2. And that appears to be all we can do. So now we have 9 times 9, which is 81. Then we still have a y squared, all over 7 times 7, which is 49. Okay. All right, how about this one? Keep, change, flip. So we're getting a little bigger numbers and more variables and stuff, but it's not hard. So nothing that we can't do. All right, so negative 5x squared, 12y cubed times 21y to the 5th over 22x, and we'll make that one negative. So we have a negative times a negative. So what does that give us? That gives us a positive. Now let's look here. We have 3 that goes in both of these. So 3 will go in here 4, 3 will go in here 7. One of these x's cancels one of those, we're left with 1. Then we have 3 here cancels 3 here, so we're left with 2. And so then we have a 4, a 22, a 7, and a 5. So it doesn't look like there's much else we can do here. So we have a 5 times 7, so that's a 35. Then we have the x to the first, y squared. And then when you have the first, you don't have to actually put it there. You can if you want to, but just a regular x is going to be fine. And then we have 4 times 22, so that would be 88. All right. How about this one? Keep, change, flip. All right. So 20x squared over 17y cubed times 15y over 8x cubed. All right. So what do we get? All right, looks like 2 will go in here 4 times. 2 will go in here 10 times. There's 2 here and 3 here, so we'll have 1 left over. There's 1 here and 3 here, so it'll be 2 left over. And that looks to be all we can do. So let's go back to purple. So we have 10 times 5, well, that's 150. And then all the variables are gone after that. So then it's over 17 times 4. Well, let's go ahead and multiply that out over here. 4 times 7 is 28. 4 plus 2 is 6. We get 68. Now we have y squared and x to the first. So we can say xy squared. Okay. And again, it really doesn't matter which order, but usually we go alphabetical order when we're putting variables. So I put the x, then the y. All right, what about the next one? Well, this one looks like we keep, change, flip. Then we have change, flip. Okay, so that gives us 8 over 3 times 5 over 12 times 3 over 5. Okay, so that should be where we need to be for our final thing after getting rid of all the divisions. And so when we do that, now we can cancel. All right, so that 3 cancels that 3, that 5 cancels that 5, 4 of those, and we have 2 left, 4 of those, and we have 3 left, and so it looks like we're just left with 2/3. Let's be different this time, and we'll just put 2/3, okay? And so it doesn't matter how many of these divisions you have, you just change, flip, change, flip, change, flip, change, flip, and just keep going, and then go ahead and do your multiplication at the end, okay? All right, we'll stop there and we'll be back.